Alright, this is Ken Rosever. I'm back on my porch. Hopefully it's not going to start raining again because I'm all set up here. But mutually exclusive events, two events, we're going to talk about that. First thing you need to understand is what does it mean for two events to be mutually exclusive. So normally we have a Venn diagram that looks like this MasterCard over here. And in that Venn diagram we have A is this whole circles, but this little one here is A and not B. This one here is A and B, and this one here is B and not A, right? And then outside we have what do we have out here? We have not A and not B, aka also known as A or B not. So those are our four regions. So region 1, region 2, region 3, and region 4. And those are their symbolic representations. Now when two events are mutually exclusive, A happening precludes B from happening, and B happening precludes A from happening. An example is, if I'm in my office, I can't be here on my porch. If I'm on my porch here, I can't be in my office. Those are two mutually exclusive conditions. I can't be in both places at the same time. So when two events are mutually exclusive, you can't be in the overlap. I can't be in my office and here on my porch. So there is no overlap. This region is empty for mutually exclusive events, which is why sometimes rather than use a four region Venn diagram as we typically do, we use for mutually exclusive this two region Venn diagram. Now I'm still going to call this region 1, region 3, and region 4 with the understanding that region 2 is empty and therefore we don't see it at all. So you can think of region 2 as being in here, but it's like a line. It has no area. It's completely empty because there is no overlap between A and B. And if we understand that, we can begin filling in our probabilities and then answering the question. So our probability of A occurring is 0.68. So A is going to occur 68% of the time. It'll never occur with B. It will only occur if B does not occur. B occurs 23% of the time. It never occurs with A. It will only occur if A does not occur. So given that information, we can compute the probability that A occurs and B does not. Notice it says but here, but is the same as and. So symbolically I can write the question A as find the probability of A and not B. Now normally that's region 1 in the MasterCard. Well here region 1 is the complete circle, so the answer is just 0.68. And why is that? Because A intersects not B throughout all of A. How can I show that? Alright, if we're not in B, we're anywhere outside of B, and that includes A, doesn't it? So if we're looking for the intersection of A, which is inside the circle, and B, not B, which is everything I just shaded in green, the answer is they intersect in here. So that's just A. For a mutually exclusive event, P, A, intersect not B is P of A. Okay? And it goes the same thing. P of B intersect not A is just P of B. Goes with this. Even though now it looks like a whole circle, it's not region 1 and 2 over here. Let me erase. It's just region 1. And just like this is region 1 and it says A intersect not B, this region 1 is also A intersect not B. Okay? Let's look at the second question. Notationally, this one is kind of interesting when you translate it. It says, compute the probability that either A occurs without B. Do we know how to write that? The probability that either, so I'm going to put a big parenthesis, and they're saying A occurs without B occurring. So that's P of A without B, so and not B. Or, so I'm uniting that with A and B. So basically, they want the probability of A happening with or without B. Well, whether this is mutually exclusive or not, anytime somebody asks me the probability of something happening with or without B, that's like, to me, that's like I'm married, and there's only two ways I go out, either with my wife or without, right? So if somebody asks me, hey, Ken, what's the chance of you coming to this party with or without your wife? I'm like, why do you say with or without my wife? Those are the only two ways I roll. So why don't you just say, Ken, what's the chance of you coming to this party? Okay. When you ask, what's the probability of A occurring with B or without B, that's just the probability of A occurring, period. And what's the probability that I'm going to show up with or without my wife? It's the probability of me showing up, period. So if you understand that, you get that the answer to B is 0.68 again. Okay? Or if you don't, you can just go back up to the MasterCard for a moment. Isn't this right here, this area right here, this moon? And isn't this right here, this biscuit right here? So if I unite them, which is what the union is telling me to do, if I put them together, don't I just get all of A? Absolutely. So it's true, whether it's mutually exclusive or independent, that or anything else, if you put these guys together, you always get P of A. So my answer is 0.68. Alright, so here's our next problem. It says events A and B are mutually exclusive. So once again, we're in the mutually exclusive category. And we suppose that A occurs with a probability of 0.43. So 0.43 is in here, and B occurs with a probability of 0.03. So 3% of the time. Compute the probability that B occurs or A does not occur. So here's B. We know the probability of it happening is 0.03. What's the probability of A not occurring? Well, A not occurring is everything that's outside of A, and that includes B. Since it includes B already, and this is a OR, they're not looking for the intersection. They're looking for me to unite B with not A. Let me write that down. On this one, for part A, they say compute the probability that B happens or A doesn't. Well, B is already part of not A, so the answer is just not A. Does that make sense? B is already in not A, so if I unite it with not A, it doesn't add anything to the result. So my answer here is 1 minus P of A. And that would be 0.57. So 0.57 is my answer. Alright, let's look at part B here. They want to compute the probability that neither the event A nor the event B occurs. So they want neither A nor B. So not A or B is basically what they're saying. So part B is asking find P of not A or B. We learned that up in here, right? When we're doing not A or B, that's the region outside. That's region 4. So all I have to do here is figure out what region 4 is. Well, if I take 0.3, or 0.43 and 0.03, that's 0.46. If I go 1 minus 0.46, I get my answer. And I'll show this to you formulaically in a moment, but that's 0.54. If you use a formula, when they ask you for the probability of not A or B, we understand that as 1 minus the probability of A or B. And then using our formula that was one of the first we learned, we know that the probability of A or B is the probability of A plus the probability of B minus the probability of both. Well, in this case, it's 1 minus parenthesis. This was 0.43. This was 0.03. And the probability of both happening is 0. So you basically end up going 1 minus 0.46. And that gives you 0.54, your answer. I hope that helps you out. I don't think I have time for another, so that'll have to be it.